Welcome to our latest edition here, creating the robot framework library with Python. You have your usual suspects here, Blake, Tim, and myself. This is part of our continuing education webinar series. I guess we started off with how to use Python with Robot Framework, which was very well received. We then went to work data management, which was not as well received because of a glitch in our scheduling, but that's okay. We corrected this one, and I can see we're now meeting our mark. So I apologize. I was the one that started this. Tim is usually the one that starts this, and he has the fun music, but I'm not so fun. So you just get to stare at the screen. But without further ado, let's go ahead and get started. Today, we're going to talk about libraries. If you use Robot Framework, used Robocorp, you ran into libraries. And so we're going to talk today a little bit about what's the purpose of libraries? Why do we use libraries? Why not just use straight Python? We're also going to talk about the overall structure. I know there's a bunch of different ways to structure libraries, but what I'm going to go over with you today is the, I guess, best practices that we consider here at Robocorp and how we structure our libraries. So that way, in case you want to be a Robocorp engineer in the future, when you grow up, you'll know how we do our libraries here. And then it would actually behoove you if you stay to the end of the presentation, because I have a little surprise for those of you that like challenges. Okay, so without further ado, let's talk about why do we use libraries? Well, first and foremost, it's about reusability. Yes.
Hey, sorry, you're not sharing anything if you were intending to.
Oh my gosh. Am I not?
We're not seeing anything on the screen.
There it goes.
And there we go. Now we've got it. Thank you.
Well, thanks for waiting for me to end. I apologize about that. I didn't switch over. Okay, so what I was talking about before is we're going to talk about the purpose of the libraries, overall structure, the best practices. And then, like I mentioned before, a little surprise at the end for those of you that like challenges. So let's first talk about why do we use libraries? Well, it's all about reusability, making stuff that's repeatable and portable that allows you to simplify the hard stuff, right? So let's say on the right-hand side here, you'll see what it takes in Python to actually create a click element and all the code related to it. So if you have to do this over and over again, or if you have to make any changes and you have to do it over again, it becomes a little bit cumbersome. So instead, by creating a library, you simplify it to simply say click element invisible and then give it the element that it's looking for. And so what that does then, it kicks off this entire workflow in the background to do exactly what it needs to do, waiting for the element to show up. And once it shows up, it clicks, and you don't have to worry about that. As with everything that we do here with Robocorp, for the most part, it's 100% open source, right? So the other benefit of that is you have other people that you can, that will be able to use your code, that can help you with your code, and you can import things from other people that have done similar things to you as well. And the final thing is, it is Python based. However, you could use the Python C API to write things in C code. But, you know, I'll be honest with you, I don't really know why I would write something in C to be used with Python. I guess there could be some reasons out there, but for me, just stick with Python, all right? So let's talk about the overall structure. Now, as I mentioned earlier, there are different ways, different methods you can do all of this. And I'm not saying our way is the best way, but I'm saying is our way is the way that we do it. So if you want to peel back the layer of onion and see how we do it behind the curtain, this is it. First and foremost, you have to bring your imports in. What different libraries, what different languages, what different items are you going to be using within your library? The one that I'll point out that is probably one of the more important things that we love here is the logging. Make sure you import the logging, because if you ever use Robocorp, you'll see all the detailed logging that we have. That's how we do it. We import the logging and we put logging throughout the library. Second thing you need is you need a class, and you need to name it. Preferably name it something short and simple, right? Because you don't want to pull in something that says library space RPA dot, this is Microsoft graph that we're going to use with Outlook extensions. Too much, right? Just RPA dot MSGraph, good enough. Next part is the scope. Now there's 3 different scopes you can use. If you want, you can research those, go out there and figure out which the other ones are and when you'd want to use them. We typically use global. It's just the best and easiest way to do that. The document format, as with everything in coding, there's different ways to do things, different methodologies, different ideas, different concepts. We used REST, just what we've done. Final thing is you need our keywords, right? What exactly are the keywords or the methods that are going to be used in your library that the user can import in and use themselves? Now, if you notice, there's two asterisks, one behind library class and one behind keywords. And the reason I did that is because, in all honesty, those are the only two things you need to build a library. You need a class and you need keywords and methods. That's it, nothing else. The other stuff, like I mentioned, is just typical best practices, what we like to do here, and what makes your code more robust and more usable or more user-friendly. The final two items that I want to say just as another caveat is some extras. I mentioned this before, logging. Put the logging in. It helps so much whenever you're troubleshooting to figure out what's going on with the robot. And the good thing about it is whenever they use your library, they don't have to do extra logging themselves. It's automatically in there for them. The final thing is the @ keyword. Before any of the keywords that you want to have published in your library, you should put @ keyword. Now, you don't have to do that. You could use an underscore, but it just makes it more readable and more easily followed if you use the @ keyword. So before any method that you want to make visible to the customer, you use the @ keyword. So on that note, enough about me talking. I'm going to pass it over to Blake, and he's going to kind of walk you through how we do our libraries and show you the introductory of MSGraph library. If I stop sharing. Blake, you're muted. Blake, you're still muted.
Can you hear me now?
Now we can hear you.
Weird. My line mute showed open, but it was still closed. Okay. Sorry about that. Okay, so you can see my screen, everybody? Super. All right.
Yep.
So let me get right into it here. Find the beginning of my class here. Oh, that's right. Not in the right mode. Make sure I'm in the right mode. And great. Okay, so now, like Eric was talking about, all you need really to start is a class. So best practices are to put together a file, obviously your package or your module. In Python, modules are files, files are modules. So the module is MSGraph.py. If you name the class the same as the module, then the import to the robot is very simple. It is the same. You don't have to find the class inside the module. So, for example, a robot importing the files module from our normal RPA framework library would simply be able to do rpa.excel.files. So now, if it was MSGraph, it'd be rpa.MSGraph, like that. So instead of having to do something else, you don't have to do that as long as you name the class and module the same. So in that case, you can structure your files however you want, but this is kind of if you're familiar with Python, if you've seen Python before, a lot of them are structured similarly with this src file and then the actual code inside of there, config files, tools files, test files, PyProjects, etc., etc. But you don't need all that. All you really need, if you just need one Py file is fine. You can make a smaller repo with literally just PyProject and a one Py file, and then that can set up everything you need. Or you can do the whole package like I've got here. So it's really up to you. This one is designed this way because the plan is to put this inside of the normal RPA framework library. So this is mimicking that. Now, as for the actual code, the actual class, like I said, you match the class name. So the most important part of, and I'm going to show you a robot again to do an example here. The most important part of actually creating your class file. Like the whole point of creating a class file is that when the robot imports a library, so in this example, it's the .files library gets imported to this robot. When it imports, it creates a files object essentially, and then keeps track of it. So whenever you call a related keyword like this open workbook, that does something to the object that it created when it loaded the library. So unlike in Python where you have to manually create the objects you want to work with, Robot Framework does it for you. And as the Robot Framework, as the Python developer behind Robot Framework, you have to remember that the code you're writing has a state, and your keywords that you're giving to the robot developer manage and modify that state. And so I'll show you the example here. The open workbook, it's what most common sort of reason why you would have a state is to keep track of what is open. So on the back end here in the Python behind open workbook, all it does is it closes the current workbook, that's fine. But really, this is the important part. Self.workbook, so self refers to the class, that object that gets instantiated by the robot framework when it gets loaded, and it loads it, and then it saves it to that state. So then that state becomes the state of the object throughout the entire robot run, which is why we're using global. And then that's the state that it will be in. And then further keywords might change it. For example, doing stuff to the Excel file or doing stuff to SharePoint via MSGraph, whatever. And then, you would close, save, whatever you want to modify the resource finally. And so, like I said, most common applications of using state inside of your robot framework library is authentication or keeping files open. Authentication is why MSGraph keeps a state, is to keep it authenticated to the MSGraph API. But obviously there could be other reasons to have state. So let's dig into it a little bit. Now, the first thing that happens when you're writing a new class is you have to write the init or the initialization function, which is common to all Python classes. But in Robot Framework, it is always best practice to make sure any arguments you would want to include on instantiation are optional, because most robot developers would not expect that a library they import would need an argument to be imported. Because if you have an argument that's required, you would have to include it after here, or else it would fail and break. So make sure they're always optional. If you want, you can provide them. You don't have to. What I did here is I provided a couple of different ways to get started. So if someone already knows their ID, client secret, they have a user token or etc., they can set that on library import if they prefer. And then what that does is the initialization, most important part is get a logger, which is what we've been talking about logging. We get a logger and save it to, again, a class attribute. And then if we get client ID and client secret, we can start up a client for MSGraph and save it again to an attribute. These attributes then stay the same or change throughout the life of the class in the robot. And that's what you're really working with as a robot developer. They don't necessarily know that. Now you all do, hopefully, or maybe you did already. That'd be cool. But either way, that's sort of what, as a Python developer developing Robot Framework, that's what we're managing on behalf of the robot developer, so they don't have to manage the state. So really, you need to think about, like, what does the robot itself, which is to say the class, needs to keep track of so the robot developer doesn't have to. That's really what you're trying to solve as part of this whole abstracting the Python up into the robot, is you're helping to remove some of that complexity so that they don't have to manage it all themselves. Now, let's talk a little bit about that @keyword decorator, a little bit more information about that. Again, it's not required. If you don't use the keyword decorator, the robot framework system will import every function available in your Py file, which could produce unintended consequences if you have a lot of imports. So if you have a lot of imports, you might end up actually creating functions that are not really keywords. So it's best practice to always use the @keyword. Once you've used one @keyword, which is imported via the that import statement, once you use it once, it turns off the automatic function creation, so that only things with the decorator @keyword will actually become keywords. And so now let's dig in a little bit to the first keyword that I wrote a few of the keywords for this library already, mostly related to authentication. So this first one is using class attributes, which is what we talked about in the initialization function, get them started as like the self.client, self.random state, etc. These are the things the robot's keeping track of. These class attributes should be set as the keywords do things. So you generally would want a keyword that does something to class attributes or uses a resource you've saved as a class attribute. Now, these arguments are exposed to the robot. You may have seen them. I'm sure you've seen them as you've done robot development. So this open workbook, I'll show you the signature. It's taking one argument here. Its signature is path as a string, and then an optional data only equals false. So that has the one. We have a couple of extra ones. So these are optional strings as well as a redirect URI. Now, if these are, and then the last one is a special permission bundle. So I'm going to tell you a little bit about the permission bundle. This is an enum class. Enum classes are neat ways to manage constants inside of a robot framework, because if you've ever used some of our RPA framework libraries, you may have noticed some of them take sort of like all caps, like flags for certain keywords, like there's all sorts of them, but this one is like, for example, basic. So like all capital letters, basic, you may be in the examples you've seen. But on the back end in the Python world, I actually want something more meaningful than basic. So if I use an enum class, which I will bounce up to show you, I can describe what basic means to my Python function, my Python class. And in this case, it means offline access and user.read. It's a list. And so what this does is that now when the robot developer writes all caps basic, the robot framework interpreter will receive that as a string and say, well, but my type hint says that it needs to be a permission bundle, and permission bundle is an enum. Okay, so if it's an enum, then I'm going to take and compare the string the robot developer gave me. I'm going to compare it to the names available in the enum class, which in this case is just basic. And if one of them exists, I'm going to return that permission bundle class object, which is essentially a constant. And each enum constant is a name and a value. And then I'll show you how the value works in a second. This is a good way to make it easy for robot developers to use flags in your, like, multiple choice flags in your keywords. Now, the actual code, we're setting a random state, which is part of the cryptographic functions of an OAuth that gets saved into the class. So it holds on to it for future, because you'll need to compare that to the final response. If there's not a client already set up, it configures one with the client ID and client secret given to us in this case, which changes the actual resource. So it creates a client resource and then sets it. And then finally, it returns an authorization URL, which is the underlying client. So this underlying client is actually a different Python library entirely. And that's the whole point of this specific library, is to wrap a Python library that's not designed for robot framework stuff. So we're turning something that's not robot framework into something that is robot framework by wrapping it with this class. And so basically all you have to do is, like, what are the common calls that a robot developer might need to make, and then turn those into functions that just handle the stuff that the robot developer wouldn't handle, which is to say, holding on to the state, for in this example. And now this next keyword, which is actually used above. So you'll notice that the keywords you create in Python can be used inside of your Python class to make it easier for you as a Python developer, but also get used by the robot developers. So in this case, if they already have a MSGraph client, like all the information, they want to configure it directly, they can do that with this keyword, which allows them to directly modify that underlying resource by setting a new client, new redirect URI, and possibly passing in a refresh token, which in OAuth terms allows it to re-authenticate an existing session from prior, like day or two ago. In MSGraph's example, it's 90 days, I believe, before it expires. And so if you're at all familiar with the OAuth flow, you've probably done it before a couple of times. Like if you use GitHub and you want to authenticate for example, Robocorp's control room to GitHub, so you can get GitHub, your repositories into our control room. That actually uses the OAuth flow. And so it bounces you to GitHub and you authorize our app, and then it bounces back to control. That's all we're doing here, except for we have to do it in a way that allows a user of the robot to get an authorization URL, go through that, and then have the robot catch the final URL that the user had, that copy paste it basically, and then save it. And then they hold on to the refresh token in the vault. That's sort of the whole authorization flow we're doing here. And so this authorize and get token is the kind of the most important part. And this is where I introduced the idea of fail fast checks. So if you have a keyword in your Python library for robot development that needs some other resource to exist before it can start, because you'll notice, and I'm going to use my other thing here, you'll notice that the init creates the client if it's given a client ID secret, or it sets it to none. So if it's set to none, then doing anything on it would fail because it's none. It's null. So the fail fast check is a simple function that just checks to see if the client is still none, and if it is none, I'm going to return an error. And here's the first example of using custom errors. So custom errors are very simple, just the name of the error you want as a subclass of exception with a little bit of information. You don't really have to do anything else. You can do other things to the error, and then you might want to look into Python tutorials on writing custom error classes. But this is the simplest way to be able to turn error messages back to the robot developer into specific error messages from your class instead of an underlying class that doesn't mean anything to the robot developer. And so in this case, we throw an MSGraph authentication error with some information, and then they'll know that it wasn't configured and they can do something about that. Oh, lost my history, so I'll just scroll back down. All right, so that's the whole point of the fail fast checks. I do another fail fast check that doesn't have its own function, which is to say if there's no random state, well, then we need to authorize a URL first. And then finally, we use the actual underlying resource, that self.client, which again is a state on the class, an attribute on the class that's being saved for us. And the robot is simply calling keywords to modify it. It does the exchange code function, which actually hits the API and then returns a user token. And then we set the user token internally, because without the token, we can't do other stuff. So we set the user token, and then we return the refresh token, which the robot developer would need to handle and put into the vault. And now, as a quick little future hint, the final version of the library I've been working on in the background before this webinar, and hopefully it will actually do some cooler things where, like, the robot you'll be able to just give it a vault name, and it'll actually just on the back end keep your tokens kept track of inside the vault without you really having to do anything, which is kind of what the whole cool, like being able to really get into robot development, to be able to develop libraries. That's kind of the whole point, is to take away a lot of the complexity from the robot developer, so they can just say, hey, log me in, do this thing, get this thing, modify this thing, done. Like, that's kind of the goal, is to help make things a lot easier from a robot development standpoint. And now, for the sake of time, I'm going to scroll down to the actual, like, a really functional keyword beyond just authentication. In MSGraph, there's a simple, like, me object, which is the currently logged in user. It's kind of like the easiest hello world example from MSGraph's API. You just get me. And so in this case, we use the get me. I have two of those fail fast checks. The new one also checks to make sure we have a token, because I can't do anything without a token. And now you can chain these like this, or you could also theoretically modify this to include this. So, like, this is also a good idea. You know, if requiring a user token would always, you know, first require a client, you could always do it like that too, and then you wouldn't have to do that. So there's options you can think through. And then we do a little bit of work with the properties keyword here, properties argument, which is a string or a list of strings. So if they give me a string, I'm going to split it by comma separated value, which is most common. And then, you know, we're going to turn those into properties. And then because the MSGraph uses OData, I believe is the format, then you have to define your selected properties in a very specific way. And this is again where you as a Python developer for the robot developer can simplify things. So instead of expecting the robot developer to know that they need to give me a $select equals some list, I allow them to give me a more natural list as either a string with separated by commas or just an actual list, which you can create in Robot Framework, and then passing that in, and then me as the Python developer handles that for the underlying API, and then it actually runs it. Now, this is, like we've said, this is supposed to be coding live. So let's do a little bit of that. I started on this already. Got to close it because I made some changes and then open it back up. There it goes. Okay. So now I started a little bit here. I added a couple more keywords, but kind of like an important part of MSGraph is being able to access the drive functionality, the OneDrives, the SharePoints, etc. And so I started working on the find a OneDrive file, which is kind of like do a search. And now, so I have a to-do here. The first thing is fix the parameter names. Now, why would I want to make sure my parameter names? So this, I have a params name. If I scroll up, I'll show you, I also have a params here, but it's query underscore params. So this is where style and consistency are very important, because you have to think about the fact that the robot developer is going to be using your keywords. And your goal as the Python developer is to reduce kind of any headache they have on their end, right? So you would want to make sure that your params have similar names. If they're used the same way, you want to make sure that they have similar types when they're used. So you want to give them the most consistent experience possible from a developer standpoint. So I'm going to fix the name, and that'd be why. And see, the type is a little different too here. So maybe I want to fix the type hinting so that it's properly set up, which is important. Oops, copied a little too much. That's fine. All right. And so now, okay, so we fixed that. Great, super. All right. So now the first thing I do here is actually, I'm going to skip some of the stuff that I might have done in the magic. I'll show you. I have kind of an in the oven sort of style, but I'm going to do a little bit here. So like my params, the actual params I'm going to give to the API, I always want to add in the ID as that selects, because you saw here that we've got this select, right? But now I always want to get back the object ID. I've not actually practiced on the API directly like with Postman yet, so I don't know the exact response yet. I only have the examples from Microsoft's documentation, and it did not include the object's ID in the return value. So I'm going to make sure that select always includes it, but that could happen. It's already happened here. I already set up a select here. Many other keywords might have a select. So my first thought was to start rewriting the same function I already have. But whenever I start to rewrite code or think I already wrote it, I'm gonna go copy paste it. I say, no, wait, stop. If I've already written the code somewhere, then why not reuse the code? Isn't that the whole point of the Python library is reusability? So if you ever feel like you're gonna copy paste a code, just don't. Instead, make it into a function. So I will show you the final function, but basically I'd want to be able to do, add ID, and I want to be able to pass them in my query params and get back new query params. And so this add ID, I already wrote it up, but basically it just takes the query params, checks if it already has select. If it doesn't, then it's going to add it. Otherwise, it's going to handle it, and it's going to add ID to it and return it. So a little bit quick, but basically the idea is that if you have functions or if you have pieces of code that you've reused, almost every case it can be turned into a private function inside the Python library. And if you are new to Python programming, private, quote unquote, private functions or methods inside of a class start with an underscore. Technically, they're not private. You can access them from outside the class because there's no such thing as privacy in Python. But most IDEs respect it. They won't show it to end user developers, and Robot Framework will not import anything that starts with an underscore from a method standpoint, even if you don't use @ keyword. And so I'm going to go ahead and show you the magic a little bit, because I'm going to show you the logger, and then we return it. So really, when it comes to logging, I'll just do that real quick before I show you the finalized version. So logger, if you remember, was an attribute we created on the initialization right there. Logging.getLogger with name, and name is just the name of the module. So we can use that whenever we want. We can use the debug function and pass, we can pass in something like, for debugging purposes for myself, for as a developer, or for the robot developer, they can get additional information. I want to be able to let them directly see the params that I'm going to pass to the API. So I use an F string to interpolate the params right into the string. Other Python developers might use other ways to format a string. Based on my research, the F string doesn't add much performance overhead in all reality. So there's no reason not to use it. And so the final thing is to actually use and perform the functionality. And so for that purposes, I'm going to pull it out of the oven for you here and show you it already completed. So here's the sort of the completed find OneDrive file. We got that add to, we got a little bit of extra stuff because the underlying class doesn't support me. And that's why I talked a little bit about that future hint where the new final version of this library is going to have some more cooler features. That's because the underlying library was the wrong choice. And I've done some work on the back end, but for all you here, this implementation is a really good demo of how to build keywords. So I kept it for this discussion, but the final version that you might see would not be using the this same library. But either case, if you ever run into a circumstance where you've got something that you're going to implement someday, but you can't implement yet for some reason, there's the not implemented error that I've used a few times. Just tells the robot developer, hey, I can't do this yet. Try it a different way for now. And then finally, got the debug I already talked about, actually performs the search item with the query that was given to me, which in this case is a string. And I didn't talk about this, so let me stop for just a moment and say, the way you define the signature, as it's called up here, will determine how the robot has to use it. So if you don't give it an optional, like there's no equals behind here, the robot has to give it a query. It doesn't have to give me a user, it doesn't have to give me a query params, but it does have to give me a query. So I know I'll at least have that. And so that's why at the end we can search items with that query. And then I have a info. Really, it's best practice to include at least one logger.info for every keyword. Otherwise, when the robot developer goes to like the log, that task log, and they open a keyword, it's going to show nothing besides the first sentence of the doc string, which may or may not be helpful. So it's always good to give back something, preferably something that has some data interpolated into it so that they can actually see what's going on a little bit. And so the final thing here is to return the proper value. This response is actually a response object. And so this is again where you as the Python developer needs to think about how the robot developer is going to use what you give them, because they don't know what a response object is. They can use objects. I don't know if you've used some of our libraries that do return actual objects, but that allows you to do dot notation, so object dot some attribute. But a lot of times robot developers don't expect that, so it's better to give them more what they expect. So in this case, they would expect a list of dictionaries. Each dictionary would be one of the files that matches the string. So in this case, I have to parse the data and get the value out of that data from our response object. And so that's sort of the basics of library creation. Like I said, the most important part is thinking through how to simplify things, make things more straightforward, so that when the robot developer is using your client, they can manipulate the state that's inside your class or client, and make it easier for them and how they want to work. And another important thing that I try to consider, like, because I've developed a few components of RPA framework, the HubSpot library specifically was mine. Get something out and get it useful, rather than perfect it. So, you could write, MSGraph has a lot of functionality in it. It's got SharePoint, OneDrive, users, Active Directory, directories, notebooks, calendars. I don't even know if I already said that. So there's so much you could implement, and it would take you a very long time to implement all of it. So it's more important to implement useful functions first, and then iterate and add more as you develop. And then and the other thing is always expect and take feedback, because other people have good ideas too. For example, the underlying library here was kind of the wrong one. to use. It's not wrong, it works, it's just not the best one. There's a better one that I have since found because one of our developers pointed it out to me. And so the final implementation will use that library instead. So, but again, I think that's pretty much most of it. So is there any questions I can answer now?
Well, I wanted to add something real quick that you said, Blake. That was very good, and said get something out there and get people using it, because then more ideas come in with that, right? And I think that's really, the power of open source, power of working with a bunch of different people across the globe is, we put stuff out there, and you'll notice sometimes we'll put out, RPA framework 15.0.0, and then next day we'll put out 15.1.0. The next day we'll put out 15.2.0. It's because, there's just so much. And look at the MSGraph, like you mentioned, it do so much that it's sometimes hard to hit every single point and make it perfect the first time. But that's the glory of the open source community, is you put it out there, you guys we work together, we find issues, and then I like to say, fix it forward. People say, oh, you always have to roll back. No, we don't roll back, we fix forward. We fix what we did and move it forward, and never, going back on what we have. So that's a good point to bring up, Blake. I appreciate that. Tim, what questions do we have, if any?
Yeah, we've got a question that came in here that was asking about, so if someone wants to write a library and they don't necessarily want to extend it into the RPA framework, they don't want to write something into this. Maybe they want to write it for their company, or they want to just write it for themselves. They want to, post it on their own GitHub, things like that. How can they write a library that isn't necessarily part of this larger, community of libraries that is RPA framework?
Sure. Yeah, so like I said, kind of at the opening, the simplest way to write a library is literally just a Pi file. So, I mean, honestly, I guess that's just super quick. I'll just do a new file here. Sure, text file, and let's tell it that it's Python. I can type, and then say, import logging, and then I got my class, and now I'm a library. That's the easiest way to start. Just get just one class, one Pi file, save it, name it the same as my class. So I'd save this myclass.py, put that in a robot, share it around, import it in that robot, use it. That's it. If you want to do more interesting things like having poetry keep track of your development environment, stuff like that, then you got to add the PyProject.tomls and other stuff, start packaging it, stuff like that. But our reality, you just need a single Pi file.
Awesome. Yeah, for people writing at home where they, just want to be able to write a simple library and don't want to extend all this. Yeah, that's the best way to get started. Another question that we've got that came in, and maybe you can talk a little bit about kind of the CI/CD pipelines and some of the things that you might do if you were building a library, but someone's asking, at what length roughly should you start to feel that your keyword needs to be broken up maybe into smaller functions or methods? So, at what point would you think that, hey, maybe this keyword's just a little too much?
Sure. Well, if you were to be developing inside of the RPA framework with all of our dev dependencies configured and the IDE configured the way I've got it here, the Flake, Lint, Pylance, etc., built into VS Code will actually tell you when it's overly complex. If you use too many arguments, if you use too many indentations, if it gets too long. But I'd say that there's no hard and fast rule. It's a matter of getting what you need to get done. And I think for me personally, the biggest reason why I write a private function like require client is because I'm going to reuse it. That's pretty much the main reason why I would rewrite a function. Is to simplify from each function to make it atomic, right? So every function should sort of be its own little thing with its own little scope that's managing its own little pocket of the universe, of its universe. I think in that way myself. I'm kind of a functional first programmer. So like this function is in scope, and I'm going to try to do stuff in just my function. And so like, if you're writing that way, you can simplify the problem ahead of you in each individual function. So like require client, I can focus on just making sure that the client is there. the add ID, I can focus on just saying, hey, I have query params, and all I want to do in this little function is just update it and then pass it back. So this simplifies your thinking for each individual function. And then you can do more complex stuff by chaining lots of functions together. And if you ever dive deep into sort of long-standing Python libraries, you'll see lots of functions, etc. And that's because of this functional approach. And then now, so I guess specific line length, I'm not sure. We can take a look a little bit at, I think the line lengths are going to come mostly from your documentation, which is something I forgot to discuss. You want to make sure to include examples. You want to make sure to describe what the keyword does. You want to describe any notes. You want to describe the parameters and how to use them, what gets returned. And then again, any code block examples of actually using the keyword in a robot framework and or in Python. But like as far as line length, I think it depends on what you're doing. I've seen some longer functions that can be 50 lines long, up to 100 lines long of actual like functional code. But, I've seen lots of short ones too. I don't know if there's any hard and fast rules. So now, what was that about the CI/CD pipeline you wanted to hit on?
Yeah, I thought maybe it'd be good as well. As people develop libraries, obviously there's a lot of, tests and checks and things that go into, some of the making sure the library is sustainable and gets out there. So a lot of times, with CI/CD pipelines, there are certain checks you can do. Are there any checks that you recommend with a CI/CD pipeline, kind of before you push your library maybe into RPA framework or even into their own, private library packages?
Yeah, absolutely. So that's where some of this stuff comes in. I use Invoke and Poetry. Invoke allows you to set up tasks for CI/CD because it can be invoked as part of a CI/CD pipeline. And so I have, tests built in. So, I can do invoke test or do just the Python tests, and it will execute tests. And this, I didn't get into this because developing PyTest unit tests is its own webinar. So, but you can build those into your CI/CD pipeline if you want, using GitHub Actions or all sorts of different ways to do it. Depends on your CI/CD pipeline. Ours is just a connection from GitHub to our control room. So you would probably need to run them as part of like pull requests inside of GitHub rather than via the actual deploy step.
Okay, perfect. We have another question that came in where someone is asking about, they have a lot of client projects they do, but they're maybe smaller, right? They may be maybe more one-offs, or maybe they're just not necessarily as large as something that we would do with an RPA framework. At what point should someone think about, doing something like a .resource file, where it's just, a simple robot file with some keywords they want to use? Maybe when should they think about doing just a .py file and having their own Python libraries versus building out a full class and a full, full library with the class structure that you've described here?
Sure. So yeah, building a straight module that's kind of written like a Python script, which is to say no class, is totally valid. And it will import every single function you put in there to the robot, and it will do whatever you write in the functions. And that's totally acceptable. Now, if you need to manage state inside of a single instance of your class, like MSGraph or like the Excel.files, if you're opening a file, if you're familiar with Python, it's kind of like context management. It's like a with statement. The robot sort of acts as your context manager. And so you want to have the state saved in the class, any attributes related to it, properties, etc. That's when I'd say it's kind of imperative. You could theoretically do that with constants and things set at the beginning of the of a script style, but I don't know how well that would work. I would really recommend classes if you need to save the state inside of the Python between keywords. So if one keyword does something like open a workbook, you don't want to pass back a handle because the robot developer, like somebody that's not you, isn't going to know what to do with this handle. So instead, you kind of hold on to the file handle as the Python developer. So that's when you really want a class.
Excellent. And we had another question that came in that I think is going to be along the same lines. So someone's asking, if you don't want to write a full class, but you do want to have functionality in multiple different bots, how can they write something that does that without having to write a full library?
Sure. So we're inside of an Excel example, one of Tim's actually he wrote. But let's pretend we want to do exactly what you just did. Well, that's relatively easy. My function dot pi. Great. Okay, so def my function, and we want to pass it some, I don't know, arg. Sure, whatever. This is fine. And then I clicked a button. Whoops. And then, we return to, I don't know, let's pretend this is something that actually exists. Do something. So like that. That's it. That works. You can import my function as a keyword now in tasks.robot. I can even show you how you would do that. My function.py. And then you would be able to use, theoretically, you'd be able to use my function now inside here. I think my function, there it is. Ta-da.
Excellent. And can you also show someone how they would do something very similar to what you just did with a .py file with maybe a .resource file? So if someone doesn't necessarily want to even get to the Python level, how can they do something similar to a library or similar to this py file in just a robot framework?
That's how I kind of got first started doing that. So my resources.resource file. So a resource file is a robot file that doesn't have tasks, and that's it. So a lot of time you can have settings, and you can import libraries, etc. So you could import these libraries here. You could import them here, and then you could do keywords, my function, to, so it doesn't conflict. And then now, we do something, which of course will fail because do something doesn't exist as a thing. But we need arguments, right? So arguments, and this is the same as any other keyword. It's exactly the same. So, so then you would, let's see, actually we'd have to save. That's essentially the same. Now it's the same. So like that.
Excellent. So people have the option of either creating full classes if they want to keep things with state going. They also have the option of creating .py files or creating .resource files if they want to do something similar to a class without having to worry about state and things like that. That's awesome. We've got another question here where someone's asking, when are we going to get this MSGraph library released in RPA framework?
I think that's a save for after questions.
Okay. All right. So we had a question come in as well earlier where someone's asking about when you had your Python function or your class up, you had used equals none in several contexts. When is it appropriate to use an equals none versus using an equals and then doing a double quote? So just having a kind of a blank there. What's the point of the none versus a blank quote?
So a none is a Python null, which is non-existent. It's nothing. It is how optional, actually this type in optional is just an alias for union of whatever and none. And in double quotes with nothing inside is an empty string, which is actually something, it's a string. But it is falsy. So any ifs based on it would also fail because it's a falsy value. So it's functionally different from the perspective that it's none versus something, and then whether or not it's a string or not a string. So it really depends on how most Python functions I've seen with optional keywords use none, because in Python you can pass everything to everything because type hints don't matter except for to developers to see what they should be. Python will accept it even if it's not what you define it to be. So.
Excellent. And then I think another question that came in here as well. Can you elaborate on the concept of library scope? So what are the different scopes available? And then when would you potentially want to use one scope over another?
Yeah. So scope is, when I talked about how the state gets saved in the instance when it gets imported, there's 3 scopes: global, test, and suite. So if you were to set this as test, then every single time, so test is the same as task in RPA world. So if in an RPA instance, if you wrote a task file with multiple tasks in it, which I'll try to do super quick because I know we're running out of time, just to show you a little bit. So like if we have keywords, we have tasks. Okay, so if I had multiple of these in a row, and then I defined my robot.yaml just to execute all tasks, and then it would pass through each individual task. If you set the scope to test, each time a task starts, it would instantiate a new class object. So your state would be lost between tasks if you used the test. Now, if you used suite, that refers to an individual .robot file. But again, you could write your robot to execute all tasks inside of a folder. So you could have multiple .robot files inside of one folder getting executed in just order. So in that case, if you used suite, a new instance of your class would get instantiated every single time a new .robot file is entered into from a task execution standpoint. Global keeps one state for the whole entire robot run, which is how most of our RPA stuff works. Most RPA developers expect the state to stay the same inside of a robot, no matter how you write your robot.yaml, I mean.
Excellent. I don't think we have any more questions at the moment, so maybe I will turn it into Q&A here. If any other questions, please feel free to write them in. We'll try to get to you after the webinar. We'll try to get you an answer. I think we'll go ahead and turn it back over to Blake and Eric for the rest of the presentation.
Yep. So there was a lot of questions about the MSGraph library. And first of all, can you guys see what I have here? Am I showing stuff?
Yep.
Okay, great. So we'll talk about that one sec, but just wanted to go through this. If you guys are wanting to take a screenshot to say, what is it do I need to do a library? Take a quick screenshot of this, and then we're going to move on to the surprise at the end. Okay, so I'm very competitive and I like prizes, and hopefully you guys are as well. So what we're going to do is we're going to publish this MSGraph library, what we have so far, but we're going to challenge you to finish it off. Okay, so what are we going to do with that? Well, like I said, we're going to publish the MSGraph library. For those of you that attended and stayed till the end of this, you're going to get an email on Friday that lets you know where this repo library is, what the requirements are, and you can go at it. The people that did not attend but signed up, they'll get it Monday, right? So you'll have the weekend to kind of look at it beforehand. What do we want you to do? Well, first of all, we want you to create a branch of that library to get your own. We want to complete all the keywords. There's about, what, 6 or 7, Blake, that we put in there we would like for you guys to complete?
Yeah, about.
Yep. Once you complete those, don't forget to document. Do all the best practices we did here because we're going to use that library for everybody else. And then we'll start the grading on every Friday. So what we're going to do with that is you will submit the information, you will submit your library, and we'll look at the dates and times, and whoever on Friday, whoever was the first one, will grade theirs. If they hit all the points, they win. If they don't hit all the points, we'll provide you feedback and move on to the next one. And we'll do that until we find a winner. And just to make it easy for everybody, the grading won't occur till Friday. So if you submit it on Wednesday, you're not going to hear anything till Friday. If you submit it on Friday, you will hear something on Friday. Like I mentioned before, the first complete submission will win. It will be released this Friday. And so what will you win? Best thing I could come up with, the $500 Amazon gift card. If Amazon isn't something that you guys use or not available where you are, that's okay. Let me know and we'll work something out. But the idea is we want to make something available to you guys. We want you to be part of our community, part of the Robocorp family, and help do that. Not only will you get the gift card, we'll announce it in our Slack channels. We'll announce it on LinkedIn. We'll give you the credit that you deserve for helping us build out these libraries. So on that, we do have a couple minutes left if there's any other questions. that we can answer?
So we have another question that came in. So when you come up with a new library, how do you determine whether it's something that the community is going to be wanting? So at what point should they submit this for their own personal use, or when should they potentially submit this for community use?
I would say based on like whether or not people are clamoring for it, I guess, and whether or not you want to develop something for yourself that you think other people might want to use, and just make it public. That, like the RPA.HubSpot library, as far as I know, no customers were using HubSpot or asking for a library in RPA framework, but we, Robocorp, needed it. And I'm like, I can just make it an actual library for RPA framework, and then it's available in case somebody does need it. And somebody actually did end up using it. So that's my answer.
The two parts that I'd add to that is, one, the big one is make sure that it's legal. Like, make sure that there isn't what you're trying to attach to, whether it's a proprietary system, doesn't say, hey, don't use robots. Like, if it's a government website or something, they may not want you to use robots for, something like that. So make sure that if you're going to publish it, it is actually legally available to be able to publish. And the second part of that, then I'd be, if it doesn't meet that, then why not publish it? There may be someone out there that's looking for exact that library for you. And that's how you get this community going. Just put stuff out there and see who uses it.
Yeah, and when you put it out there, you might get good feedback to do something better than what you thought. For example, like I found out that the library I was using was not the best one. So put it out there. You learn.
So,
excellent.
Okay. On that case, I think we'll go ahead and just wrap it up. Like I mentioned before, those of you that attended and stayed till the end, looked at your email early Friday Eastern time, and you'll get the information of this webinar, as well as a link to the GitHub repo where you can pull your own branch and start working towards that. And then good luck, happy hunting, happy development. Talk to y'all later.